Let me jump into things here. All right. See if this is a little bit better. I think for these first couple of pages here, guys, it would just be best to kind of, don't try to copy down everything. Maybe copy down the phrase, the language of algebra. And we'll talk about what exactly that means here. But I just didn't want you to feel like you had to copy down everything that's on the screen, because it's like an introduction to what they call the language of algebra, or algebraic expressions. Okay. So, excuse me. So if you saw a phrase like this, a number plus 9, okay, if they ask you to, in algebraic language, as it were, could you write out something plus 9? So that would say the same expression. And let me help you out here. You could say x plus 9, okay? That is some number, okay? And we just chose the value x for it and then said plus 9, okay? Number 2, h minus 7 here, okay? I'm just going to take the letter h and write minus 7. So that is h minus 7. Then it's spelled out. We're just making it using the normal symbol. Another expression, number 3. The product of, and we know product means multiplying. Okay, I'll put a little times above there. The product of 3 and y. Would you think about that for a moment? How would you write that on your paper as just a simple algebraic expression like 1 and 2? Okay. How about 3y? When you stick two numbers next to each other like that, that means times. Okay, and another way is to express it like this: 3 in the parentheses y. Whoops, that's going to be a funny looking y there. Okay, that also just means times. Okay. All right, number 4, c divided by 6. C divided by 6. Probably I'm going to write it like this: c over 6. That is c divided by 6. As a numeric, as a kind of an algebraic expression. 5 times z, and again, we're just going to go, hey, it's just 5z. 5z means 5 times z. R subtract 4, I'm just going to go r minus 24. I should have said 24 there. Okay, so let me show you a couple more just to kind of give you the idea of what we're just talking about, how phrases spell out, how we put them into what are called algebraic expressions. Now for this one, I think I'm just going to speak it out loud. Here you've got an algebraic expression, v minus 19. So I could just write the letter v and then spell out minus 19, okay? 2b, I could just say, or 7b, 7 times b. Or number 3, you've got r divided by 6. I might just write r, spell out divided by 6. Hopefully this is starting to kind of catch on. 8 plus t, 8 plus t, okay? Y divided by 9, again, you would just write it out with words. Y divided by 9. D plus 8, d plus 8. So again, we're just kind of familiarizing you with the idea that what these kind of expressions look like, okay? Let's take a look at one that's kind of in a word problem form. And so Kara is X years old. Write an expression That tells you how old she will be in 8 years. Okay, so she's X years old right now. That's what she is right now, okay? They want to know, write out an algebraic expression that will show how old she will be in 8 years. Well, X is the now plus 8 gives me how old she would be in 8 years. Number 2 here, before going to the store, Steve had Y dollars in his pocket. Don't know how much that is. It could be $30, $50, we don't know. He spent $3.40 at the store. Write an expression that represents what he has left. Okay. He starts with Y amount of dollars. This is how much money he's got when he in his pocket when he goes to the store. He spent, we know that spent means minus. Okay. So Y minus 3.40 will give us the answer, okay, to that expression as a story problem. Okay, just again, what we're doing here is just like kind of introducing you to a little bit of the language of algebra here. All right, the next concept I want to talk about, which again, this will be a review. We actually got into this in my 60 class last quarter for those who happen to have it. But there is a principle which I'm just kind of curious why I don't actually have it written here. Yeah, it's actually called the addition principle of equality. So let's just do this. Let me just add it for you here, okay? All right, there's my little post-it note that I'm going to, I want you to kind of write that somewhere in your notes here, okay? It's called the addition principle of equality. And, and basically it means, well, I'm giving you a moment to write it down. It's the idea. You can add positive or negative numbers to both sides of an equation to create an equality. And so this addition principle means you're always either adding positive or you could say adding negative numbers, or you could just say subtracting. Let me show you what I mean here in a moment. All right. So if I take my number 6 here that I've got on the screen here, all right. And number 6 says x plus 9 equals 15. A couple of important concepts when we're solving one-step algebraic equations you're trying to get x. You're always trying to get the variable, like in this case, it's x. In number 7, it's x. In number 8, the variable, the letter is m. So we're solving for m. And then there's x again. So it can be A, B, C, or D. You're always trying to get whatever that letter is. You're trying to get it by itself. Okay. And once you get it by itself, and then everything else is kind of on the other side, you've pretty much solved for x. But, so that's the rule, is in order to solve these one-step equations, we're trying to get x by itself. That's rule number 1. Okay, so if you wanted to add that to your notes, to get x by itself. Okay, so I'm going to just write this down here. Get x. Come on, pen. What's going on here? Wow, it's doing that thing again. Good timing. Oh, that's fun. Hang on a second. Let me just shut everything else down that I possibly can. See if that helps. All right. So I'm looking at the equation here. X plus 9 equals 15. All right. So I want to get X by itself. So if you think about how I would get X by itself, if I subtract 9 from this side here, then X is now by itself. So what I would do is I'd subtract 9 from this side. Wow, I don't know what is going on with my pen. Sorry, guys. Let me try the old unplug it and plug it back in trick. Yeah, so come on, you got me here. Okay, so if I subtract 9 from that side, then I've got to subtract 9 from the other side, okay? Whatever I do to one side of the equal sign, I got to do to both sides, okay? And that's this addition principle equality. Add or subtract the same thing to both sides, okay? So if I have 9 plus, or plus 9 and a minus 9, those are going to cancel out, okay? They become basically 0. So what I now have is X equals, and then I've got 15 minus 9. Well, 10, 6, that equals 6. If I subtract 9 from 15, I get 6. So I have isolated X by itself and done the same thing on both sides, okay? Let's look at number 7 here. All right, number 7 says X plus 11 equals 32. It's the same idea. I'm looking, oh, this is exactly like the one above. So I'm going to subtract 11 from this side. I'm going to subtract 11 from this side. And I'm going to get that then cancels out, we chose another color here. That cancels out the 11s and I get 11. I'm sorry, X equals 21. Okay. All right. That is some very basic one-step algebra. And it's actually kind of fun. I'll be honest with you. I enjoy algebra once you sort of start getting the hang of it, it becomes like a little puzzle. Really, it is almost like a puzzle. Look at number 8 here. M minus 7 is 23. All right, this is my principle of adding or subtracting. In this case, I've got a minus 9, so I'm going to add 7 to this side. So I'm going to add 7 to this side. So these cancel out, okay? The 7s cancel out, and that leaves me M equals 23 plus 7 is 30. Okay, so I've just done the same thing I did on both sides, okay? I did want to show you a couple of these kind of weird ones because you're going to run into this in your homework here. Number 9, we'll call this a weird one, guys. And here's why. We've got 59 equals 27 minus X. You see how you got a minus X here? All right. Technically, we shouldn't be showing you this in a introduction to one-step equations, but I notice it's in the curriculum and in your homework. So I wanted to show you what to do in this case, okay? All right, first thing I would do is, if I subtracted 27 from both sides, 27 here, I'm gonna get, okay, this is a 2 and a 3 equals negative X. All right, and this is why this really shouldn't be, you see how these cancel out here and this subtracted to this. This really shouldn't be in this class because we did our one step, but we're technically as an answer, you shouldn't have a negative x. So whenever you get this, I wanted to show you this in your home for your homework and when you encounter this in the future. If you ever do all the steps and you have a minus x or a minus m or whatever, the way to get rid of that minus is if you multiply it by -1. Okay, a negative times a negative, you'll remember, is a positive, right? And so that means I would take this times -1. So what I did is I did the same to both sides. To this side, I multiplied -1. So these two negatives cancel out. And so I get just x equals, and now I have a negative. Why did I write, oh, this is times it. So let me write this -1 like this times it, okay? All right, sorry guys. You guys know I'm only running on about 2 cylinders here, so. All right, so we've got this -1 times the -1 times 30, which would give me -32. All right, so there you have a positive x equals -32, and that solves the problem. So that's the solution. When you get a negative x as an answer, multiply both sides by a -1, and that will get rid of the negative on the x side. Couple more examples. Just going to do a bunch of these tonight. So I've got -7 plus equals y plus 11. Okay. You notice the y, the variable's on the other side of the equal sign. But I'm going to do the same principle. I want y by itself. So I'm going to subtract 11 to get rid of it here. Subtract 11 on the same other side. Okay. That's going to give me y equals 11, 17, 18, -18. Okay. So yeah, I just added up my, when you subtract from a negative, you go negative, further negative. So remember the rule of subtracting negatives is when you have the same signs, add up the numbers, keep the sign. All right. Number 11 here, 12 minus 2 equals d plus 7. What I would probably do first is I would just simplify what's on the left side first, okay? That doesn't change it, it just gives me the same thing it equals. 12 minus 2 is 10. That equals 10 equals d plus 7 here, okay? Now, from here, hopefully we can kind of take it from here and go, oh, we know how to do this. Subtract 7 from this side, subtract 7 from that side, and that leaves us d equals 3. Okay. All right, for the sake of time tonight, I'm going to move on to the next slide, guys. Make sure I get through everything still breathing here. Okay. I think I've shown you enough here. Again, something like this is a little bit of a longer problem. You know, you might simplify first. 12 minus 9 is 3 equals, and you've got 3 minus 4 plus w. So 3 minus 4 is -1 plus w. Okay. See how I just took these two and combined them into -1. I simplified. And then from there you could solve. Add 1 to each side and you get w equals 4. Okay. All right, I'm going to slow down here a little bit. I want you to write this in your notes here. Okay, be sure to get this. Hopefully this will work okay. That'll work. It's called the division principle of equality. So we learn the addition subtraction principle of equality. And then this is what's called the division principle. Now I should kind of give you the heads up that they usually just call it the addition principle of equality and the division principle of equality. And the reason why is because you can kind of simplify it. If I wanted to get rid of a -4, I would add a 4. So I'm adding a 4. If I wanted to get rid of a 4 on one side, I could add a -4. And so I'm still adding technically the -4 instead of just calling it -4. So in that sense, you're looking at it as adding the same, in both cases, adding. Okay. Well, in some ways, this is kind of true as well, but divide both sides by the same thing to get x by itself. Okay. That's kind of how the textbooks put it. Okay. Another thing that you might want to do is you might want to put this note, which is I kind of gave myself some space here, and the idea that you're going to do the opposite. Okay, and I'll put in parentheses times or divide. Okay. And that's kind of what's going to go on here, is that you're going to do kind of the opposite of what's going on in the equation to get it by x by itself. So let me give you a moment more to copy this down, and then I will show you these last couple slides. Okay. Hope you're ready for number 1 here. You've got 2x, which we now know means 2 times x, okay, equals 12. So what is the math that's going on that left side of the equal sign? It's times, right? What is the opposite of times? Division. So here's the way we would write it out. If I wanted to get x by itself, okay, if I divide this side by 2, then what's going to happen is those 2's are going to now get canceled out. 2 goes into 2 one time, and so you have 1x, which is the same as just x. Okay. So I noticed that the operation going on in the equation was multiplication. So I figured out to nullify that, I'd had to do division. Whatever I did to that side, I got to remember to do to the other side as well. So I've got 12 divided by 2 as well. Notice I'm just writing it like a fraction symbol, okay? So now these 2's cancel out, so I have x, essentially 1x, but it's just x, same thing, equals 6. So I just solved a one-step equation using the division principle of equality, okay? I should note to you kind of a really important concept right now, if I could squeeze it down here in the bottom right corner here. You guys know if I wanted to get rid of 1/2, if I wanted to multiply by something so it becomes 1, I would multiply it by its reciprocal, 2 over 1. And that gives me 1, okay? Likewise, if I had the fraction 3/5 and I needed to multiply something times this side to get rid of the 3/5, what would I multiply that side by? I would multiply it by 5 over 3. Okay, see the idea? So when you're needing to get rid of a fraction, if you multiply by the reciprocal, it becomes 1. Now, essentially, that's kind of what we did here. We multiplied 2x by 1 over 2, which is just like dividing it here, okay? All right, number 7, or number 2 down here, very similar type problem here. I've got 7 times, so equation is timesing. I'm going to do the opposite. I'm going to divide to get rid of the 7. Okay, and I got to make sure I do the same thing to the other side. The 7s now cancel out because 7 goes into 7 1, so I have 1m, which just means m. It's the same as m, okay? Equals 7 goes into 49 7 times, okay? Look at number 3 here. Nice equation. I've got 4m, negative 64 equals 4m, okay? I see that I've got multiplication going on on the side of the variable. So I'm going to divide both sides by 4, okay? And hopefully, by the way, let me finish this equation just to kind of show you where this would go here. So this would cancel these out. I'm left with m equals 4 goes into 64. How many times? What is it? 16. My brain is 4, 20, 4, 5, 6. Yep, 4 times. So 16. So 4 goes into 64 16 times. Now, this would give you negative 16 as an answer because it's a negative here. So negative 16. And yes, we can have answers that are negative numbers. Like I previously mentioned, we just want to avoid having the variable answer as a negative. All right, so I've got number 4 here, last one. Negative 3x equals 27. Now, if I wanted to kind of do two things at once here, okay, if I divided the negative 3x by a negative 3, now notice I chose negative 3 because I'm thinking I want to get rid of this negative, okay? Negative divided by a negative is a positive. Because a negative times a negative is a positive. All right, so I have to divide this side by negative 3. And so what that does, I chose that negative number there because now that cancels, not only does it cancel out the 3's, but it gets rid of the negative on that side. So I now have x equals, well, 3 goes into 27, I'm sorry, 3 goes into 27 9 times. But 3 times what? Well, a negative 3 times what gives me a positive? It must be a minus 9, because a minus 3 times a minus 9 would give me a positive 27. Okay. All right. A couple more here. They're getting gradually more complex here. I'll give you a moment just to copy down a couple, at least 5 and 6. And we'll just kind of work our way through these. Hang on a second. I'm going to peek here. All right. Okay, folks. I may not do all of the whole equation, but I'll get you started on how I would do this. Number 5, since I have multiplication going on here, I'm going to divide both sides by 4.2. Okay. I don't think I need to do this. You could figure it out with your calculator that you get to use. Okay. Number 6 here, 14 equals x over 2. Now this is a good example of that. Multiplying by the reciprocal, like 1/2 times 2 over 1 gives me 1, right? So what I'm going to do is multiply both sides times 2. Okay, so I'm going to take this side times 2 over 1 in a sense. And this side times 2. Okay. See how I've done the same thing to both sides? And these twos cancel out, so I get x equals 28. Okay. Number 7 over here, I've got x over 3, same exact thing. Okay, what I'm going to do is, I wrote it down here just to kind of, so it doesn't confuse people when they look at this video here. Okay. What I would do is I would multiply this side times 3 over 1 and this side times 3. Or just 3 times negative 15. I'm doing the same thing to both sides, and then I would solve the equation. Okay. 8 is b over negative 4 equals 6 plus negative 9. I would just simplify the equation just to make my life a little bit easier. I'd just rewrite it out as b over negative 4 equals, and then I'm going to do the math here. 6 plus negative 9 equals negative 3. Okay. Now, I'm going to look at this equation here. I've got b over negative 4. I want to get rid of the negative 4. So if I multiply 4 over 4, 4 over 1, and actually what I'm going to do is multiply negative 4 over 1. So I'm going to multiply this times negative 4. Now let me show you why I did that. Okay, you probably see why I multiplied by 4, right? But because I got the negative here, when I get rid of it in the side of the exponent, the variable, I chose negative 4 to multiply to both sides. The negatives cancel out, and I'm left with b equals, and negative 3 times a negative 4 is 12. Okay? So just kind of watch for that. If you see that you're going to get a negative number, then multiply a negative something times those things. All right. Let me just do 1 on this page. Okay, guys. And let's do number 9 here. Just so you don't get confused, you see how you got 72 equals 14x plus 2x, okay? All you're going to do is simplify this the equation. So you're going to really write it out as 72 equals 14x minus 2x here. Well, that's 12x. That's all you do. You're simplifying this. Since you have the same thing, same variable x is here, okay? You can simplify it to that, and then you can solve from there, okay? Again, on number 10, I would multiply this side by negative 1 and add up 16 and 15 and get 21 and multiply it by negative 1. So, okay. Take a moment here, folks, and you can copy down the idea that they call this, again, the division principle of equality. And we've kind of been already doing this already, but in the cases we were always kind of multiplying something. In fact, now that I think about it, we've already been doing this on the last couple of slides. Same idea. Excuse me. X over 5, you guys know we'd multiply this side times 5 and get x equals 5 times 4 is 20, okay? Number 2, n over 3, so multiply 3 by both sides. Number 3, 3/5. Oh, this is a good example. Let me show you this one right here, okay? Remember I said to get a variable by itself at, just 1y or 1x, okay? You want to multiply the number by its reciprocal. So what I would do here is 3/5 times let's just call this y here, 3/5 y, times 5/3. Okay. You see that these are now, this is going to all cancel out here and just give us y by itself. Okay. Equals 9/1. What did we do on the left side? We multiplied by times 5/3. Okay. And then I would solve it from there. Okay. So again, if you get a weird looking fraction, don't panic. Just multiply by the reciprocal of it and it goes away. And again, in this number 4 example here, I would use a negative 7/5 because the negative times the negative here would cancel out. Now I have a positive y equals, and then 15/1 times negative 7/5. Okay. All right. I hope we're still doing okay here, guys. Very last slide, and I think we're doing pretty good for time here. Yeah, we're doing great. Again, just looking at number 5 here, I'm going, hey, look at this problem here. 7/6y equals 16 plus 5. Well, if I want to just kind of rewrite it and simplify one step at a time, I could go 7/6y equals 16 plus 5 is 21. Okay. Then I can look at my problem and go, okay, how do I get y by itself? I'm going to multiply this side by, this is 7/6. So I'm going to multiply this by 6/7. So whatever I do to that side, I'll make this 21/1 times 6/7. That cancels out the fraction on the left side. So I now have y equals, if I kind of did my cross canceling here real quick, 1 and 3, 3 times 6 is 18. 18 is my answer. Okay. All right. Again, in number 6 here, I see I've got a negative 5/7. So I'm going to multiply the negative reciprocal. So negative 8/5 times both sides. Okay. And I think that is pretty much the basics of what they call one-step equation. And I think everything else, especially the first several where we're just adding and subtracting to both sides, you know, the same number, it starts off fairly simple. Okay. These ones here, you know, not too complicated, but just be aware if you get a negative variable, then you know, the way in algebra students just start in their head, they just automatically know the answer is x equals, and then, you know, -1 times whatever the other side is. So, because they just know, they do that in their head real fast. Okay. All right. Having said all that, hang on a second.